Okay, so we're probably only going to have 11 through 14 on this rapid fire. On Monday, 6 students went to the tutoring center at the same time, and each one was randomly assigned to one of the 6 tutors on duty. On Tuesday, the same 6 students showed up. So hold on, we're going to label these tutors. 1, 2, 3, 4, 5, 6. We're going to pretend they're all standing in a row, and that way I only have to focus on the order in which the students sit down. So we're kind of fixing the tutors because they will be sitting in some order of the desks, and we're just going to have the students come up and line up in front of them. So we're going to say A here, B here, C here, D here, E here, F. Okay. Now on Tuesday, the same 6 students showed up, the same 6 tutors were on duty, and the students were again randomly assigned to the tutors. What is the probability that exactly 2 students met with the same tutor both Monday and Tuesday? So when the students sit down on Tuesday's order, they're going to have 6 factorial arrangements. And I'm going to write that as 6, 5, 4, 3, 2. We don't need to write times 1. The first thing is this is the way that the students can arrange themselves with the tutors on Tuesday. But we now want to count favorable outcomes in a separate way. So I'm going to say that there are 6 choose 2 ways to decide which students are at the same location. I'm going to go ahead and say that it's E and F that get the same tutor over here that they had on Monday. That of course is 15. It will eventually cancel with this. Next, I have to arrange the other 4 so that none of them are in their current seat. How many ways can I do that? And I have to multiply it by the number of ways I could choose the 2. It doesn't matter which 2 and which 4. All 4 people are going to have the same number of ways after the 2 are chosen. Okay? So I'm going to have A sit in one of these seats. And I'm going to go ahead and have A sit in this seat. So A's seat is now open and A is in where D's seat was. How many choices did A have? A had 3 choices. So from here you've got to be really careful because essentially we have to pick somebody. You can kind of think about it this way. We're going to pick someone to go in A's seat. That's the seat that someone has to move into. It needs to be B, C, or D. There are 3 choices for who's going to sit in A's seat. Now, once that is decided, we don't have any more choices. The reason is, let's say that C goes over here, right? Then what has to happen with B and D? Can B stay in their seat? No. B has to go to C's seat and D has to go to B's seat. They don't get a choice anymore. Once you figure out who goes in A's seat, the other 2 are going to have to switch, not switch spots, but the person who's currently has nobody in their new seat needs to move out to the other open seat. I could not, for instance, put D here because B would stay there. So you're going to get that, and that's going to be it. Let's say you kind of wanted to try to prove it to yourself. Think about the way, once A has sat down, what are all the orders that C, B, and D could sit in? It could go C here, and then B is going to have to go here, and D here. This is given that A is locked into the 4th seat now, okay? Now, if I said instead of C sitting in A's seat, where in front of tutor 1, instead of C, I put B there. So if I did that instead, then what? We would have what seat open? B is open. B sat here. Oh, we kind of messed it up, didn't we? We had C, D, B, A. Okay, so if B sits in A seat, then who's left to place? D and C. Could C be in their same seat down here? They could not. They're going to have to go to here, and B, or rather D will have to go here. C has to move out of their seat. This is number 1. This is a second Tuesday version. Now if we do a third Tuesday version, and instead of C or B sitting here, D goes here, then now what's left is that B and C would still be here. They're going to have to switch. they're going to have to go as C here and B here. And these three ways that we found right here is this three right here. It's the same exact three, because once that's been decided who's going to sit in A's seat, C, B, or D, the other two are automatically determined. So this is going to be 15, canceling 5 and 3. 1, 3 cancels the 6 to give a 2. We got a 4, a 2, and a 2. You have a 3 over 16. It will be answer choice B. If you're looking for intro to counting and probability or how to get better at this content, even if you've taken those classes elsewhere, there might be opportunity for you to be able to improve. I do have a class starting the first week of December. Email me at my channel email if you are interested in that. We did it one way, but we said, let's convince ourselves. So we gave ourselves the cases of who sits here, and did the other two people have a choice? They did not have a choice at any time. They always had to make a switch. At least one of them had to move out of their seat, and so it was a fixed outcome from that point forward. Let's get to problem 12. Okay, so I didn't want to try and draw this one on the whiteboard because of the hexagon. So I'm going to go ahead and do this problem here, number 12, on my laptop touchscreen. So the first thing is, what is the size of my pen? Too big. Okay, the figure shows an equilateral triangle, a rhombus with a 60-degree angle and a regular hexagon, each of them containing some mutually tangent congruent discs. Let T, R, and H respectively denote the ratio in each case of the total area of the discs to the total area of the enclosed polygon. So what I'm going to do is I'm going to go down here and call that R, and I'm going to go over here, and since that's going to be 30 degrees right there, and this angle is going to, how do I know it's 30? Because it's going to go to the midpoint. Basically, if I drew this straight up, it'd be the altitude. It's an equilateral triangle. It'd be an angle bisector and all those kinds of things. In fact, let's zoom way in on just that one. We might zoom back out later. So this would go to here and be 30 degrees. And I'm calling this R, and this is 60. So this is R rad 3. Then we're going to connect the centers. That's your general rule for all circle problems, R, R, and R. And so from here, we're going to have 3 pi r squared over. And then what we're trying to find is the side length in terms of r. So it's clearly 2r root 3 plus 2r. So now we're going to factor out that 2r, and it's going to be root 3 plus 1. And you're going to use s squared rad 3 over 4, a small notebook concept. And so now I'm going to square 2r and get 4r squared. This is over 4. We're going to cancel now. We're also going to square this, and we're going to get 3 plus 1 plus 2 rad 3. So now we don't need to cancel the 4 with that or anything. It's all a big product, so it's fine. So now we're going to have 4 plus 2 rad 3 r squared. And the r squareds are going to cancel. So now we have this. The ratio of t, we'll put it over here, is 3 pi over 4 plus 2 rad 3. All right, so now that's t. R is the rhombus. So we're going to go over to it. S squared root 3 over 4. Just want to make sure I'm doing it right. Factored out 2r, had root 3 plus 1, 4r squared, no mistakes. Okay, good. Now we'll go over here. When we do this one, I will draw right through here to make an equilateral triangle, which means that this one triangle on the top is the same as the bottom. They're symmetric. You can't really do that over here. I can't like draw, I mean, I guess I could cut it in half and have the two halves work out, or like we kept going this way, but you'd still have half a circle and a, half a triangle. And this one, there's a lot better benefit. You get two symmetric outcomes, and I can just focus on one because the ratio within this one will be the same as the ratio in the other, and therefore the ratio of the whole thing. So now we'll go over here and you'll have R and R. And again, this is a 30-degree angle and its opposite 30 is R. So opposite 60 is R root 3. That will be R root 3. You will have pi R squared over 2R root 3 is the side length that you're going to put right here. And when you square 2 root 3, you get 12, and 12 over 4 is 3. So you're going to get 3R squared root 3. 3R squared root 3. Think about that for a second. I'm going to get 12R squared over 4 times root 3. Yep. 3R squared root 3. Okay, so this is going to be your R. Your R is pi over 3 root 3. Pi over 3 root 3. Okay. From this point, we will go look at the other one. I'm going to erase a lot of stuff here so I can go back. You can go back and watch the video part to see all of that. I just need to get more space. And I don't want to erase my conclusions over there, but just get this out of the way so we can zoom down. Okay. We're going to have some stuff on the screen. That's fine. Now what I want to do is zoom in on this one and see, it was TR and H, right? TR and H, yeah. Okay, so we got this, annotate, erase all of this. And now, so what I'm thinking is that I'll use a very similar tactic. I'm going to come right through here and split this up, and I can see that essentially all of these are going to be, I kind of missed on that one, but they're all going to be just like that shape. We're going to have a circle in the inscribed circle of an equilateral triangle. We're going to have 6 of them, so this one is actually going to be equal to H as well. So now if we zoom back out, and look at our answers, it wants to know which of the following is true. And if you compare, obviously T is the one that's different. Right, let me move this up a little bit, I guess up to here. There we go. So T is the one that is different from the other two. We do have, yeah, T has to be, R does not equal T. H is equal to R, and there's no way all 3 of them are equal unless somehow if I multiplied this one by, say I multiplied 3 times pi over 3 root 3, I multiplied it by 3 over 3. That would give me 3 pi over 9 root 3. If you really want to be sure, check to see that 9 root 3, how does it compare to 4 plus 2 root 3? Because now this is still R, and T and R have the same numerator. The whole thing is R. And so if the denominator is bigger or smaller, we could compare it. So you could do that. You can also say that root 3 is approximately 1.7 and check that way. So 4 plus 3.4 is 7.4. 9 times 1.7 is going to be a lot larger. You could also subtract the 2 root 3 off of this side. So you would have 6 root 3 or 7 root 3 compared to 4. And clearly this is much bigger over here. So this is a bigger number, which means R's denominator is larger, making the value of R smaller because it's got a larger denominator when they have an equal numerator. So we can be very, very confident now that the answer to 12 is going to be C. And with that, we'll get back to the whiteboard and one of my favorite questions on this test. Okay, and this was one of the most interesting problems on this year's test. It was a kind of a lot of fun, depending on your definition of fun or your connotation for it. It's 2025 10B problem 13, 12B problem 10. The altitude to the hypotenuse of a 30, 60, 90 triangle, right triangle, is divided into 2 segments of length x less than y by the median to the shortest side of the triangle. what is the ratio of x over x plus y? So what I'm going to do is I'm going to draw, let's try to draw it straight on like this. And we will claim, at least, that this is 60, and this is 30, and this is 90. Okay, and we're going to draw the altitude right over to here. And we're also going to draw the median right over to here. I guess approximately the median. Okay, and this looks like the shorter piece over here. We could call this x and we could call this y. I'm going to label them as A and B, where A is x and B is y, for reasons we'll get to in a moment. So yeah, what do we do here? We got x less than y, a less than b. We can't be 100% sure yet at this point in the problem, by the way, that that is the smaller piece. You might go back to, if you had my small notebook black class, you might be thinking about secoi, which is the centroid, circumcenter, orthocenter, and incenter. And you think, well, but this is a median. But does a median cut an angle in half? No, it doesn't cut the angle in half. You'd like it. Maybe you think that'd be good. You get an angle. No, not what happens. And you think, well, should I add another median because the midpoint of the hypotenuse? Then I could get the 2-to-1 ratio that medians create. Well, centroids create at their centroid. And so you think about that. There's a lot of different things you can do here. It's almost, there's a lot to think about, right? And so you go, all right, well, what can I just add more information? I'm going to add 30 degrees here. And the reason that we're going to add 30 right there is because that's 60 and that's 90 by virtue of it being an altitude. Okay, then what? And you say, well, really don't know. What if I labeled these two pieces? It's a midpoint, right? If they said median, that means it goes from a vertex to a midpoint. Why don't I give these some lengths? I'll call this 1, and I will call this 1. And so now you're going to have 1 and 1, and that's 2. Your side opposite 30 becomes 1. What do we get over here? 60 is going to be 2 rad 3. And then you know that your hypotenuse is 4, so this part up here is 3, meaning from, if I give this A, B, C, it'd be from A to D would be 3, right? And you go again, is there some property? You really want there to be a property for altitudes and medians, and maybe there actually is one, by the way. It could be like, Euler's line type thing where you get the centroid, circumcenter, and orthocenter relationship. But you kind of try some things out. You're like, okay, I've got 90 degrees here, and I know this is 3. I even went so far as to try, I'll write this piece right here in terms of a and 3. It'd be like, right, it'd be the square root of a squared plus 9. And if I do that, we also know, by the way, that BD is equal to root 3 because you have a 1 to 2 and root 3 ratio. This is the side opposite 60. So you know what x plus y is right here. It's going to be root 3. We just don't know what x is, or a in the case that we wrote here. And so you might have gone, and this is a great thought, by the way. There's nothing wrong with this thought. You might have said, I have a Cevian, or a Chavian as they're probably called properly. I say Cevian all the time, but I'm sure that's not how you say it. Chava, I think, is the way you say his name. But this line right here, you could use Stewart's theorem. And so Stewart's theorem, you could say, well, this squared, which would be that, times the whole thing, root 3. So you could do like a squared plus 9 times root 3. And then you'll have the two pieces, which would be, you could call it a and root 3 minus a. And that would be this piece times this piece times the whole, which is root 3, and equals, and you could do 3 squared times b and 12 times a, which is 2 rad 3 squared. The problem is when you do that, it's a dead end. What you get is 0 equals 0 in essence. And so you kind of are like, well, what else do you got? Any other bright ideas? And sometimes this is where you have to say, what if I'm looking for this point of intersection. What if I put this as a coordinate plane? And we call this in comp math, it's called chord bashing. So if you can't find some nifty similar triangles type thing, and you might have hoped right here with these two vertical angles that you would get similar triangles, but you don't. That angle's not 30, this one is, so not going to work out in your favor. And yeah, you don't have like alternate interior or anything like that. So instead, we're going to chord bash. You're going to turn B into the origin, and A is going to be your y-intercept, and you're going to go down to root 3 and over 1. And oh, really quick point, by the way, they didn't tell us any lengths. Guess what that means? You can make them up. It's going to be the same for all lengths that you would choose as long as you obey all the rules of the problem. So if somebody else put, 1 for the whole side, root 3, they'll get the same answer. It's just that our algebra will look slightly different. So this line going down here, the median, I'm going to erase the Stewart's theorem nonsense because it doesn't work out. You're going to have y equals negative 2 root 3x. And this part here, how am I going to get the slope of this line through the origin? And again, they say that you don't have to know trig, and you don't, but you can say, by the way, that the slope of any line with the horizontal, if I call this theta, which is an angle, then the slope of line L is going to equal tangent of theta. So if you thought of that, and you don't have to use tangent here, by the way, you can do something else, which I'll do in a moment. But if you knew that, tangent of 30 is the sine of 30 over the cos of 30, which is 1/2 over root 3 over 2, and the 2's cancel, and you get 1 over root 3, and that would be your slope. And so you're going to get, this is plus 2 root 3 for your y-intercept of A, because you're up 2 root 3. Your other equation is y equals 1 over root 3x. Now, let's say you didn't learn the unit circle and you're not expecting to have to use it. So you didn't really think about the tangent idea or didn't know that one. Are you out of luck? No. Just drop a height from right here and you have 90 degrees. And therefore you have 30. And you know opposite 30 is a 1 to root 3 ratio. So your rise is 1, your run is root 3. You don't really care what this length is. Don't look at this 1. It's not this 1. It's the generic 30, 60, 90 proposition that, you're looking like this. So this is 60. This is going to be x root 3, and 2x. We always want nice, simple concepts to be the things that we use. We've known 30, 60, 90 since 5th grade, 6th grade, 7th grade. This is something that was accessible. You're just not seeing that when you look at it. So now you drop it down. Your rise over your run is x over x root 3, 1 over root 3. What do we do now? Well, if I can find the distance going this way, which is going to be my x value, this is x comma y. My x value is my distance from my y-axis, also a small notebook concept. And if I can find that, then I can use it to help myself get the B answer over here. So what we'll do is we'll use 30, 60, 90 relationships at that point. So what I'm going to do is set these equal to each other. So 1 over rad 3x equals negative 2 rad 3x plus 2 rad 3. You're going to multiply by rad 3. X equals negative 6x plus 6. You're going to add negative 6x. You're going to get 7x equals 6. And x equals 6 over 7. Now the x coordinate being 6/7, It is opposite 60 degrees. This right here is 6/7. I'm going to go ahead and put it on this one just because that picture's kind of cloudy over there. This is going to be 6/7. We have to divide by rad 3, which is going to give us 2 rad 3 over 7. Divide by rad 3 to get the side opposite 30, and you double that, where this will become 4 rad 3 over 7. So that is the B value right here. Keep in mind, we're looking for A, which will be rad 3 minus what you just found, 4 rad 3 over 7. So at this point, you should see that all of your rad 3s are going to cancel. This does not become 0, it becomes 1. So you're going to have 1 minus 4/7 all over 1, which we don't care about the 1, and 1 minus 4/7 is going to be 3/7. Really great problem again. Chord bashing, never forget it. If you did take my small notebook class, we went over that exact thing with the centroid problem where we looked at the concept about it being the average of the coordinates. So, when should you chord bash? It's simple. If you can't find another way, you should consider chord bashing. It's kind of a safety net. Any geo problem can be turned into a chord bash problem. You just don't always want to do that. And it takes a little bit of intuition to figure out when you should. And I don't even know, is there a better way with similar? I don't know. This is the way that I solved it. If you had another way, feel free to drop a comment down below. Let's get to the next problem. And the final problem of this rapid fire set, I'm not going to be doing 15 in the rapid fire at the time of this filming, which is currently 4:34 a.m. local time. I did not find a efficient way to get the question 15 or at all. I had broken it up into partial fraction decomposition and couldn't figure out how to navigate from there. So I didn't go back and try to solve it later. I needed to get to the 12 and things like that. Sometime in the future, I'll figure it out and get a video for it. But for now, this rapid fire will end here. 9 athletes, no 2 of whom are the same height, try out for the basketball team one at a time. They draw a wristband at random without replacement from a bag containing 3 blue bands, 3 red bands, and 3 green bands. They are divided into a blue group, a red group, and a green group. The tallest member of each group is named the group captain. What is the probability that the group captains are the 3 tallest athletes? So the deal is, we don't really care. It says one at a time, but it's a little bit like, I don't know how to explain it. We can have the 3 tallest players choose a band first, because they're all going to be assigned bands. At some point, the 3 tallest athletes will be assigned a band, and we can just focus on them and them alone. So when the tallest athlete gets a band, do we care what color they are? The first one? No, they can be any of the 9 colors, but let's assign them one. We're going to call them tallest one, and we're going to say that they got a blue band, okay? But the actual band color doesn't matter. This is going to become our fixed position that the rest of the taller players draw compared to, okay? So when T2 goes, what is the chance that when they draw the second tallest person, they get a band that is not blue? It's going to be 6 out of 8. And so let's assign them a color too. Let's say that they took red. So now when T3 goes, we're fixing this position as if this outcome has occurred. Now, given that this outcome has occurred and we've assigned it without loss of generality as red, T3 now needs to draw green, and there will be 3 green in the bin when T3 draws, and there will be 7 bands left. So this will become 3 over 4, and you will multiply to get 9 over 28. Now, you might be saying, yeah, but how do we know they draw first? It doesn't matter. They're going to be assigned. All the other things are going to be symmetric and not have any impact on the outcome. Again, if you did Intro to Counting and Probability, there's been several problems kind of like this. One would have been in chapter 9, the Think About It, with the 3 students, A, B, and C, and Billy goes to the bathroom, and the other 2 triplets, I think, are in there. I forget their name, maybe it wasn't B and C, but they are in the classroom, the teacher calls the name, and what is the probability that, you know, such and such occurs? We don't actually care about any of the other people being drawn. And so the idea would be you kind of took that into account and you ignore, you know, what other names might have come up. You just focus on the probability that Billy's name can't be called, but the other 2 names are also not called. I think it was Annika and started with a C. But go look at that problem. It's very similar to this. And again, if you're looking for to get better at probability, I will have a very in-depth view of the Intro to Counting and Probability book class coming up the first week of December. You can even have an impact on what day of the week it's on. So far I have 3 students signed up. There's about 5 spots left. Reach out through my website if you'd like to attend that class. All right, that's it. See you in the next one.